Good day, everyone. You are welcome to Science Explained. Today, we want to have a look at another question on pressure that is acting through a liquid. Now, here is a question that has to do with a swimming pool that is 7 meters deep, and there is an air bubble at the bottom of the swimming pool. So, what happens to the radius of that air bubble when it moves to the surface? That is what the question is asking us. I will pause the video for you to give it a try. Also, I want you to determine what the radius of the bubble will be at the surface compared to what it was at the bottom of the pool. All right. Now, when the air bubble is at the bottom of the pool, the radius is given to be 3 centimeters. And do not forget that the water in the pool will be exerting pressure due to its weight on this air bubble. That means the initial pressure exerted by the water in the swimming pool and the atmospheric pressure that is coming from outside, as you can see, atmospheric pressure is entering. So as it enters, it is added to the pressure that is exerted by the water on the air bubble. That means initial pressure, which is P1, will be atmospheric pressure, which is 10.34 meters, plus the pressure exerted by the water, which is 7 meters in the pool, and that will give us 17.34 meters of water. Okay, how do I know that atmospheric pressure is 10.34? Because of what we are given here. Height of water barometer. Do not forget that barometer is used to measure atmospheric pressure. So we call this height barometric height of the liquid, which is water here. It can be any other liquid. In any other question, it doesn't matter. It could be mercury, it doesn't matter. It's called barometric height, which is the atmospheric pressure acting on that liquid. Okay, now the initial volume of this bubble, air bubble, will be calculated using the volume of a sphere. As we all know, without any iota of doubt, that is a bubble. When you see a bubble, it is spherical in shape. Therefore, formula will be 4/3 pi times 3 raised to power 3, because formula of a sphere is 4/3 pi r cubed. So where r is what? 3. Now, the P2, that means the final pressure that will be acting on this bubble when it's at the surface here. Don't forget that it has moved to the surface. That means the height has increased from below. And I told you in my previous video that pressure increases with depth but decreases with height. That means the pressure at this bottom will be higher than the pressure at the surface. So P2 will be only atmospheric pressure, because the weight of the water will not have any pressure to exert on the bubble again, as it has moved to the to the surface. So that will be 10.34 meters of water. If it is mercury liquid used, it will be meter of mercury. Alright, B2 will be 4/3 pi r cubed. Don't forget, this is what we are looking for. We are looking for this r. That's why I put question mark here. So, what do we do? using the formula derived from Boyle's law. P1 V1 equals to P2 V2. That is, the product of the pressure and volume remains constant. Alright, by substitution, P initial pressure will be replaced with 17.34 multiplied by initial volume, which is 4/3 pi times 3 raised to the power 3 being the radius of the what? Of the bubble at the bottom, equals to final pressure at the surface when the bubble is at the surface. That will be 10.34 times 4/3 pi r raised to the power 3. Now, some of you might be asking why I did not convert the meters to centimeter or centimeters to meter so that all will be uniform. Of course, I should have done that, but I realized that they will be cancelling out each other. Meter will cancel out meter. Remember, this one is a meter, this one is a meter. So the meter here will cancel out. The only thing we have left is centimeter, which is coming from the radius. Now, to reduce your stress of calculation, this now depends on your level of mathematics knowledge. You don't need to multiply anything because what is here can cancel some things here. 4/3 will cancel 4/3, pi will cancel pi. So that means we can make r cubed the subject. R cubed now will be 17.34 times 3 raised to the power 3, which is 27/10.34. It is important you know how to make a parameter the subject of any given formula. That is where your mathematics plays an important role. So when you remove this cube here, what do you do here? You take the cube root. That means R will be cube root of 17.34 times 27 divided by 10.34. By calculation, we get 3.56 centimeter. Now, as you can see, what has happened to the radius of the bubble, air bubble? It has increased. At the bottom of the pool, it was 3 centimeters, but at the surface, it is 3.56 centimeters. Can you answer the reason why? Okay. Very good. Yes, you got it. Because the pressure exerted on the bubble at the bottom is higher than the one exerted on that same bubble at the surface. Why? Because pressure increases with what? With depth, and it decreases with height. That means at this point at the bottom, the pressure is high, while here low. The pressure is low. And according to Boyle's law, volume is inversely proportional to what? Pressure. That means the higher the pressure, the lower the volume, and vice versa. So definitely, once the pressure here is higher than the pressure here, it means as the bubble is moving to the surface, it will be expanding. Why? Because the pressure exerted on it is decreasing as it moves up. So that is why the radius of the bubble at the surface is bigger than the radius of that same bubble at the bottom of the pool when the whole weight of the water is acting on it. That will be the end of this class. Thank you for being here. If you appreciate this teaching, please do not hesitate to subscribe and share. Also, your comment will be highly appreciated so that it will help us to improve on our videos. See you in my next video. Bye for now.